Our planet is warming. The evidence is undeniable: melting glaciers, rising sea levels, and extreme weather events. We are living through a climate crisis, largely driven by human activity. For decades, scientists have warned about the consequences of our reliance on fossil fuels. These fuels release greenhouse gases that trap heat and warm the planet. The solution seems simple: reduce our emissions. We need to transition to cleaner sources of energy like solar and wind power. However, the shift to a sustainable future is slow and complex. Global economies are still largely dependent on fossil fuels. The infrastructure for renewable energy is still under development in many parts of the world. Even with our best efforts to curb emissions, the planet will continue to warm for decades to come. The effects of climate change are already being felt worldwide. We need a solution, and we need it now. This is where the controversial concept of geoengineering enters the picture. Could geoengineering be the radical solution we need, or is it a dangerous gamble with our planet's future? Let's explore this complex and controversial topic. Geoengineering refers to large-scale interventions in the Earth's climate system. It is a set of technologies that could potentially mitigate the effects of climate change. These technologies aim to manipulate the planet's natural systems to counteract the warming caused by greenhouse gases. One proposed method is stratospheric aerosol injection, often called SAI. This involves injecting reflective particles into the stratosphere, the second layer of Earth's atmosphere. These particles would act like a giant sunshade, reflecting a portion of sunlight back into space. This could potentially cool the planet, similar to the effect of volcanic eruptions. Another method is carbon dioxide removal, or CDR. As the name suggests, this approach focuses on removing carbon dioxide from the atmosphere. This could involve planting vast forests to absorb carbon dioxide. Other CDR techniques include using machines to capture carbon dioxide directly from the air. Once captured, this carbon dioxide could be stored underground. These are just two examples of the many geoengineering techniques being explored. While they seem like science fiction, some of these technologies are already being researched and tested, but could they really be the solution to the climate crisis? The concept of stratospheric aerosol injection, or SAI, is both fascinating and frightening. Imagine dimming the sun to cool the planet. While this might seem like something out of a science fiction novel, SAI is based on real-world observations. Volcanic eruptions, for example, release massive amounts of sulfur dioxide into the atmosphere. These particles reflect sunlight back into space, causing a temporary cooling effect on the planet. SAI aims to replicate this effect artificially. By injecting aerosols into the stratosphere, we could potentially offset some of the warming caused by greenhouse gases. Proponents of SAI argue that it could provide a relatively quick and cost-effective way to reduce global temperatures. It could buy us valuable time to transition to a low-carbon economy and develop more sustainable solutions. However, SAI is not a permanent solution. It would require continuous injections of aerosols into the atmosphere to maintain the cooling effect. While the science behind SAI seems plausible, the potential risks and uncertainties are substantial. We'll delve into these concerns in the next section. Carbon dioxide removal, or CDR, takes a different approach to combating climate change. Instead of trying to block sunlight, CDR focuses on removing the root cause of the problem: excess carbon dioxide in the atmosphere. This method aims to mimic and enhance natural processes that already absorb carbon dioxide. Trees, for example, are natural carbon sinks. They absorb carbon dioxide during photosynthesis and store it in their wood, leaves, and roots. Planting vast forests could help remove significant amounts of carbon dioxide from the atmosphere. However, finding enough land for such massive reforestation efforts is a significant challenge. Other CDR techniques involve developing technologies to capture carbon dioxide directly from the air. This captured carbon dioxide could then be stored underground in depleted oil and gas reservoirs or deep saline aquifers. While this technology is still in its early stages, it holds promise as a potential solution for removing carbon dioxide from the atmosphere. CDR methods, while promising, also come with their own set of challenges and uncertainties. The effectiveness and scalability of these technologies are still being debated. Furthermore, the long-term environmental impacts of large-scale carbon capture and storage are not yet fully understood. Section 5. The promise of a reprieve. The potential benefits of geoengineering are enticing. In the face of a rapidly warming planet, these technologies offer a glimmer of hope. They present a potential lifeline, a way to buy us precious time to address the root causes of climate change. Imagine a future where geoengineering has successfully lowered global temperatures. The intensity and frequency of extreme weather events have decreased. Sea levels have stabilized, sparing coastal communities from the threat of inundation. The worst effects of climate change have been averted, giving humanity a chance to adapt and transition to a more sustainable way of life. This is the optimistic vision of geoengineering proponents. They argue that these technologies, while not a permanent solution, could provide a critical stopgap measure. They could act as a bridge between our current predicament and a future powered by renewable energy and sustainable practices. However, this optimistic vision is just one side of the coin. The potential risks and unintended consequences of geoengineering are significant and cannot be ignored. Section 6. The Law of Unintended Consequences. The Earth's climate system is incredibly complex and interconnected. Altering it on a global scale through geoengineering could have far-reaching and unpredictable consequences. Like a house of cards, meddling with one part of the system could trigger a cascade of unintended effects, some of which could be catastrophic. One of the biggest concerns is that geoengineering could disrupt regional weather patterns. SAI, for example, could alter precipitation patterns, leading to droughts in some regions and floods in others. These changes could have devastating impacts on agriculture, water resources, and ecosystems. Furthermore, the long-term ecological effects of geoengineering are largely unknown. Injecting aerosols into the stratosphere could deplete the ozone layer, which protects us from harmful ultraviolet radiation. Altering the pH of the ocean through carbon removal techniques could harm marine life and disrupt delicate ecosystems. Beyond the environmental risks, there are also significant ethical and geopolitical concerns surrounding geoengineering. Who gets to decide whether or not to deploy these technologies? Who controls the thermostat of the planet? These are complex questions with no easy answers. Section 7. Nature's Own Solutions. While the promise of geoengineering is alluring, it is crucial to remember that we already have a powerful and effective solution to climate change: nature itself. For millennia, natural ecosystems have regulated the Earth's climate, absorbing carbon dioxide and releasing oxygen. Instead of resorting to risky and unproven technologies, we should prioritize nature-based solutions. Protecting and restoring forests, wetlands, and other natural ecosystems is essential for mitigating climate change. These natural carbon sinks absorb vast amounts of carbon dioxide, helping to regulate the Earth's temperature. Investing in sustainable agriculture practices is another crucial step. Regenerative agriculture, for example, focuses on improving soil health, which can increase carbon sequestration. By transitioning to more sustainable farming methods, we can reduce greenhouse gas emissions from the agricultural sector and enhance the Earth's natural ability to capture carbon. Nature-based solutions offer a more holistic and sustainable approach to combating climate change. They address the root causes of the problem while also providing numerous co-benefits such as biodiversity conservation, improved water quality, and enhanced food security. Section 8. A Planetary Dilemma. We stand at a crossroads. The climate crisis is upon us and the need for action is urgent. Geoengineering, with its potential to rapidly cool the planet, presents a tempting solution. But it is a solution fraught with risks and uncertainties. On the one hand, geoengineering offers a glimmer of hope in the face of a daunting challenge. It could buy us valuable time to transition to a low-carbon economy and develop more sustainable solutions. The potential benefits, while uncertain, are significant enough to warrant serious consideration. On the other hand, the risks of unintended consequences are substantial. Tampering with the Earth's complex climate system could have unforeseen and potentially catastrophic effects. The ethical and geopolitical implications of deploying such powerful technologies are equally concerning. The decision of whether or not to pursue geoengineering is not one to be taken lightly. It requires careful consideration of the potential benefits and risks, as well as a thorough assessment of the ethical and geopolitical implications. Section 9. Our choice, our future. The future of our planet hangs in the balance. The choices we make today will determine the fate of generations to come. Geoengineering, while a potential tool in our fight against climate change, should not be seen as a silver bullet. It is a last resort, a dangerous gamble with our planet's future. Instead of placing all our hopes on risky and unproven technologies, we should prioritize sustainable solutions. We need to accelerate the transition to a low-carbon economy, invest in renewable energy sources, and embrace sustainable practices in all aspects of our lives. Ultimately, the most effective way to combat climate change is to address the root causes. We need to reduce our dependence on fossil fuels, transition to a circular economy, and adopt more sustainable lifestyles. This requires a collective effort, a global commitment to safeguarding our planet for future generations. The path forward is clear. The question is, will we choose to take it?